Ballistics is a science that deals the study of motion of projectile and the factor affecting its motion. The meaning is the move of the bullet projectile. The three branches of ballistics: internal or interior ballistics, external or exterior ballistics, and terminal ballistics. Internal or interior ballistics is the study of the motion and characteristics of the projectile while still inside the firearm. The move and behavior of the bullet inside the firearm. Interior ballistics: when the firearm is loaded with ammunition, the firearm squeezes the trigger, causing the hammer to strike the firing pin. Then the firing pin will hit the primer inside the primer. There is a priming mixture, very sensitive, will be ignited such the ignition will cause the burning of the gunpowder inside the bullet. The ignition, very sensitive propellant, and the primer mixture will cause the burning gunpowder. The moment of the gunpowder will be burned, it will create pressurized gas that eventually that pressurized gas will push the bullet out of the shell that will pass through the barrel of the gun. Internal ballistics: the moment leaves the muzzle of the gun. External or exterior ballistics is the science that study of motion of projectile as it leaves the muzzle of the gun. The moment leaves the muzzle of gun is also the beginning the external or exterior ballistics. The three branches of ballistics: internal or interior ballistics, external or exterior ballistics, and terminal ballistics.
There are many different types of firearms, but only certain types are commonly used in crime in the United Kingdom. At the time of publication, handgun and saw-off shotguns predominate with over 90% of serious armed crime involving these weapon types. This section does concentrate on them, although it does also refer to guns such as submachine guns and assault rifles, which, although much less common, are sometimes used by criminals. Figure 1. Self-loading pistols. Most self-loading pistols consist of a frame or receiver with a reciprocating slide. Sometimes the barrel is fixed to the receiver, sometimes this is a separate part which moves during the firing cycle. Generally, self-loading pistols operate using a spring-operated box magazine, the bulk of which is fitted into the handle of the pistol. They fire one cartridge for each pull of the trigger, with 5 cartridge cases being ejected from the weapon. Figure 2. Self-loading pistol operation. During operation, a magazine is filled with a number of cartridges and is inserted into the magazine well. The pistol slide is pulled to the rear and released. As it travels forward, under the force of a spring, the top cartridge is stripped from the magazine and fed into the chamber. The pistol is now cocked and loaded. From this point, assuming any safety catch is set to the fire position, pressure on the trigger will fire the weapon. On firing, recoil forces cause the cartridge case to be thrust back against the slide, which is pushed to the rear, allowing the empty fired cartridge case to be ejected from the weapon. As the slide travels forwards again, propelled by a mainspring, it strips top cartridge from the magazine and feeds into the chamber. The hammer or striker remains cocked and the trigger must be released and pulled again before the newly chambered cartridge can be fired. This type of pistol will fire a single cartridge for each pull of the trigger. Once the magazine has been emptied, the pistol slide will be held at the rear, demonstrating to the user that the weapon is empty. Again, Figure 2. Self-loading or semi-automatic pistol operation cycle. A. Gun at rest with loaded magazine containing live cartridge. Slide spool rearwards and release forward, chambering a live cartridge from the magazine and cocking the hammer. C. The triggered spool the hammer strike the firing pin, which in turn detonates the live cartridge, forcing the bullet down to the barrel. And lastly, D. Recoil forces slide rearwards, extracting the spent casing. On the forward movement, a new live cartridge is reloaded from the magazine. Figure 3. Revolvers. Revolvers derive their name from the revolving cylinder that holds the cartridge. The cylindrical rotating part of the revolver contains separate chambers revolving around a central axis to align individual chambers with the rear of the barrel for firing. Cylinders typically hold 6 cartridges, but there are exceptions. Cartridge firing revolvers generally come in one of three forms: solid frame revolvers with a cylinder held in frame fixed behind the barrel. These are normally loaded via slot in the rear of the frame, known as gate. These are known as gate loading revolvers, figure 4. Hing frame revolvers, figure 5. Where the frame is hung usually at the front of the frame below the barrel, cartridges are loaded into the weapon chambers after the frame is broken open. Solid frame revolvers with the swing out cylinder, figure 6. The cylinder is mounted on an arm known as the crane, which normally swing out to the left hand side of the weapon. Revolver operation. Revolvers are designed to be fired in single or double action mode. In single action mode, the hammer is manually cocked. As the hammer is raised, the revolver cylinder rotates automatically to bring the next cartridge to be fired beneath the hammer. Once cocked, pressure on the trigger fires the weapon. In double action mode, as the trigger is pulled, the cylinder rotates automatically and the hammer is raised almost to its rearmost position, from which point it discharges the weapon. Shotguns, figure 7. There are four main types of shotgun: single barrel weapon, double barrel weapons, pump action weapons, and self-loading weapons. Double barrel and single barrel weapons operation. Most double barrel shotguns have a soak kill break action. This means that the weapon hangs just forward of the firing mechanisms, exposing the rear of the barrels in side-by-side weapons. The barrels are laid alongside each other in over and under shotguns. The barrels are one above the other. Submachine gun and assault rifles. Figure 8. Neither type of weapon is commonly seen in gun crime in the United Kingdom. The main difference between the two is that submachine gun uses pistol ammunition and the assault rifle an intermediate cartridge, one lower powered than a normal rifle cartridge. Both weapon types are generally selective fire weapons in that they can fire single shot, each requiring a separate pull on the trigger for each shots, or full auto, where the gun will continue to discharge for as long as the trigger is depressed and there is ammunition in the magazine. Ammunition, figure 9. Metallic centrifire bullet cartridge construction. Conventional metallic centrifire bullet cartridge consists of four constituent parts: a cartridge case, propellant powder, a primer, and a projectile. The primer, the ignition system of the cartridge, sits in the base of the cartridge case. The propellant is housed inside the cartridge case, and the projectile sits in the cartridge case mouth. In common parlance, people often refer to a round of ammunition as a bullet, whereas technically bullet refers only to the projectiles. Figure 10. On firing bullet cartridge, the cartridge case expands slightly, forming a tight gas seal at the rear of the barrel. This helps to maintain sufficient pressure to propel bullet down the barrel at optimum velocity. Test for the presence of gunpowder residue.
Paraffin test, thermal nitrate test. The purpose is to detect gunpowder residue or nitrates on a suspect hands. How is used? A warm paraffin wax is applied to the suspect hands to form a mold. The mold then sprayed with a reagent like diphenylamine. The result it will be blue coloration suggests presence of nitrates. Grease test. The purpose is to identify nitrates residues from gunpowder on clothing on skin. How it is used? A treated paper is placed over the suspect's surface and sprayed with a sulfanylic acid and alpha-naphthalol. The result is orange or pink spots indicate nitrates and used to help estimate distance of firing. Marshall and Tiwari test. The purpose is another method to test for gunshot residues, especially focusing on detecting lead. How is used is to involves chemical treatment of suspect surfaces. The result is color change suggests presence of lead. Harrison and Gilroy test in the purpose to detect lead, barium, and antimony common element in primer residue. How it uses chemical reagent that produce specific color exchanges on skin. Swabs or samples, the result is red is barium, yellow is lead, and orange is antimony. The use of this is stronger than paraffin for detecting actual primer residues. Walker test can estimate firing distance from gunshot residue in clothing. Uses to photographic paper treated with chemicals like grease reagent placed under the clothing, then exposed to the heat. The result is a pattern of nitrate particles on the paper. Gives clues about how far the shooter was.
Wound ballistic is the study of the effects of projectiles such as bullets on the body or other target. It's a specialized area of forensic science and medicine that helps understand how a bullet behaves after it hits a person or an animal and what kind of damage it causes. Wound ballistic are three phases. First is internal ballistic. Internal ballistic, also called interior ballistic, is the branch of ballistics that study what happens inside a firearm from the moment the trigger is pulled in until the bullet exits the barrel. Second is internal ballistic. Internal ballistic is the study of bullet behavior after it exits the firearm barrel and before it hits a target. And last is terminal ballistic. Terminal ballistic is the study of penetration of missile in different type of targets, and its study of wounding capabilities in animal tissue is involved the study of bullet resistance materials such as jacket and vest. The bullet when passing through human tissue will consume some of or all of the kinetic energy to the surrounding tissue, resulting in throwing the tissue away from the bullet but in original manners, leaving a temporary wound capability which has larger diameter than the diameter of the bullet. The temporary nature of discovery results from the natural elasticity of the human skin, which regains its original structure after the bullet has passed.
The temporary cavities, the radical strength of tissue around the bullet wound drop which momentarily leaves an empty space caused by high pressure surrounding by the projectile that accelerate materials away from its spot.